The Body, A Guide for Occupants by Bill Bryson. Here's a fun thought experiment. What would it cost to build you from scratch? Not your personality or your memories, but literally, what's the price tag on all the raw materials that make up a human body? When Bill Bryson was young, a teacher told him you could buy all the chemicals inside a person for about $5. Pretty humbling, right? You're worth less than a decent sandwich. Well, in 2013, the Royal Society of Chemistry decided to fact-check this claim. They calculated the cost of all 59 elements needed to construct a human being, using Benedict Cumberbatch as their guinea pig. Turns out, we're a bit pricier than expected. Your oxygen runs about $14, hydrogen, $26. But then things get expensive fast. The 30 pounds of carbon that gives you shape? Nearly $70,000. Add up all those microscopic traces of rare elements, and you get a very specific total, $151,578.46. But here's where it gets wild. Even if you gathered every single ingredient, even if you assembled the brightest minds in human history and gave them unlimited time and resources, they still couldn't create a single living cell. Forget about a thinking, feeling, dreaming human being. That's the miracle of you, and that's exactly what we're about to explore. Today we're diving into Bill Bryson's masterpiece, The Body, A Guide for Occupants. Think of it as the owner's manual for the most complex and miraculous machine you'll ever possess. Bryson has this incredible gift for taking intimidating scientific concepts and making them feel like stories your fascinating uncle tells at dinner. He's written about everything from the history of the universe to the evolution of the home, selling millions of copies along the way because he understands something crucial. The greatest stories are the true ones. And there's no truer, more personal story than the one happening inside you right this second. By the end of this journey, I promise you'll look at yourself differently. You'll understand the silent, relentless work happening within you every moment, and you'll appreciate, maybe for the first time, just how staggeringly improbable your existence really is. So let's begin our tour of the most extraordinary thing in the universe, you. To really understand the story of you, we need to start ridiculously small. Everything you are comes from about 7 billion atoms. That's a 7 with 27 zeros trailing behind it. These atoms, carbon, hydrogen, oxygen, and a sprinkle of other elements, aren't special. You'd find the same stuff in dirt or rocks. They're mindless, inert particles, without a single thought or intention among them. Yet somehow, for the brief and precious span of your life, these atoms have come together with an urgent desire to be you. They'll build and maintain every system, repair every injury, and power every thought, all without a single moment of your conscious attention. This is the miracle of life. The only thing special about the elements that make you is that they make you. These atoms assemble themselves into the basic unit of life, the cell. Your body is a universe of about 37 trillion cells, all working in near-perfect harmony. But even the cell is a paradox. It's packed with busy little components, ribosomes, mitochondria, proteins, but none of those individual parts are alive. The cell is just a container, a little room. Yet when you put all these non-living things together in that room, you get life. Science can't explain that final spark. It's almost like magic, and it's happening trillions of times over inside you right now. At the heart of each cell sits the instruction manual for building you, your DNA. If you unraveled all the DNA from just one cell, it would stretch about 6 feet, but you have so many cells that if you took all your DNA and laid it end to end, that impossibly thin strand would stretch for 10 billion miles. It would sail past Pluto. Think about that for a second. There's enough of you, literally, to leave the solar system. You are cosmic. And this DNA carries a story that's almost eternal. You'll fade away eventually, but your genes, that instruction manual, have been passed down in an unbroken chain for 3 billion years. For you to be here right now, every single one of your ancestors, from the first single-celled organism floating in a primordial sea, to the small furry mammal hiding from dinosaurs, to the early human learning to walk upright, every single one had to survive long enough to pass that genetic information forward. You are the result of an unfathomable winning streak. This genetic code provides instructions for building proteins. Proteins are your body's workforce. They're the enzymes that digest your food, the hormones that carry messages, the antibodies that fight off invaders. Everything useful happening in your body is done by proteins. Yet for all this complexity, nothing's in charge. There's no tiny general in your head directing traffic. Each cell, each protein, each atom responds to signals from its neighbors in a constant, chaotic dance. And somehow, out of this chaos, comes perfect, coordinated action. Out of this dance comes you. Now let's zoom out and look at the structure that houses this miracle. We'll start with the part you see every day, the outside. Your skin is your largest organ, weighing about 10 to 15 pounds and covering roughly 20 square feet. It's your body's first line of defense, a waterproof, self-repairing shield that keeps your insides in and the bad stuff out. The outermost layer, the part you can touch, is made entirely of dead cells. Where your body meets the air, you are, in a sense, already dead. You shed these cells constantly, at a rate of about 25,000 flakes a minute. If you run your finger along a dusty shelf, much of what you collect are tiny fragments of your former self. We're all, silently and continuously, turning to dust. Beneath this lies the dermis, the living layer, packed with blood vessels, nerve endings, and the roots of your 5 million hairs. It's also riddled with millions of tiny sweat glands. We tend to think of sweating as kind of gross, but it's actually one of the things that made us human. Most animals cool themselves by panting, but you can't pant and run long distances at the same time. Our ancestors evolved the ability to sweat from nearly hairless skin, turning us into living air conditioners. This ability to dump heat allowed us to run for miles under the hot sun, to become endurance hunters. And it allowed for the dramatic enlargement of our most temperature-sensitive organ, the brain. In a very real way, sweat made you brainy. Skin is also where we get our color. And as anthropologist Nina Jablonski discovered, that color is just a tiny sliver of epidermis, a reaction to sunlight. People with darker skin evolved in places with intense sun, and their skin produced more melanin, a natural sunscreen. People in regions with less sun evolved lighter skin to better synthesize vitamin D, which is crucial for bone health and immunity. Biologically, there's no such thing as race. There's nothing in our skin color, hair type, or bone structure that defines us as fundamentally different. We're all just variations on a theme, beautifully adapted to the places our ancestors called home. As one professor told Bryson, showing him a sliver of skin no thicker than paper, that's all that race is. This outer layer isn't just a barrier, it's a bustling ecosystem. Your skin is home to about 100,000 microbes per square centimeter. You aren't just a person. You're a planet, teeming with trillions of tiny living things. Your private load of microbes weighs about 3 pounds, the same as your brain. We used to think of these microbes as germs, as invaders to be scrubbed away, but we now know our lives would be impossible without them. They help us digest food, extracting vitamins and calories our own bodies can't. They train our immune system, teaching it to distinguish friend from foe. We have about 20,000 of our own human genes, but we carry around as many as 20 million bacterial genes. From a genetic perspective, you're about 99% microbe. This is their planet. We're just living on it and in it. Of course, not all microbes are friendly. A tiny fraction, just over 1/400 species, cause disease in humans. And these tiny mindless entities are responsible for 1/3 of all deaths on the planet. This brings us to one of the greatest stories in medical history, our battle against them. For most of human existence, a simple scratch from a rose thorn could lead to a fatal infection. Doctors were helpless. Then, in 1928, a notoriously messy scientist named Alexander Fleming returned to his London lab after a holiday. He noticed that on one of the petri dishes he'd forgotten to clean, a patch of mold was growing, and around that mold, the bacteria had been killed off. A less observant person might have just tossed it in the trash. But Fleming realized he was looking at something profound. That mold was a species of penicillium. It was the discovery of penicillin, the world's first antibiotic. But the story doesn't end there. Fleming couldn't purify the substance. That task fell to a team at Oxford University, led by Howard Florey and Ernst Chain, a brilliant but difficult German émigré. Working through the darkest days of World War II, they managed to produce just enough to test on a single patient, a policeman named Albert Alexander, who was dying from an infection that started with a scratch in his rose garden. The effect was miraculous. Within days, Alexander was sitting up in bed, fever gone, but their supplies ran out. The scientists even tried filtering the penicillin from his urine to re-inject it, but it wasn't enough. The infection returned, and he died. The race was on to produce penicillin in bulk. The project moved to America, where scientists searched for a more potent strain of the mold. After testing samples from all over the world, the winner was found on a cantaloupe melon that a lab assistant named Mary Hunt bought at a local grocery store in Peoria, Illinois. That pretty golden mold was 200 times more powerful than Fleming's original. Every bit of penicillin produced since that day descends from that one random cantaloupe. Antibiotics changed the world, but in his Nobel Prize acceptance speech, Fleming issued a chilling warning. He predicted that microbes could easily evolve resistance if we used these drugs carelessly. Seldom has a Nobel speech been more prophetic. Today we face a crisis of antibiotic resistance. We use antibiotics for conditions they can't cure, like viral colds. In the United States, a staggering 80% of all antibiotics are fed to farm animals, not to treat sickness, but to fatten them up. As a result, bacteria are fighting back. They're evolving into superbugs like MRSA, which resist our most powerful drugs. We're fast approaching a day when we may not be able to perform routine procedures like hip replacements because the risk of infection will be too high. The day when people die again from the scratch of a rose thorn may not be far off. Now let's travel deeper inside, to the most extraordinary thing in the entire known universe. It weighs just 3 pounds, has the consistency of soft tofu, and it's sitting inside your head. Your brain. The great paradox of the brain is that it creates your entire world, yet it has never seen it. It lives in total silence and darkness, like a prisoner in a dungeon. It has no pain receptors, literally no feelings. The world comes to it only as a stream of electrical pulses, like Morse code tapped out along your nerves. And from this dry, neutral information, it creates for you a vibrant, three-dimensional, sensually engaging universe. Your brain is you. Everything else is just plumbing and scaffolding. Just sitting quietly, your brain churns through more information in 30 seconds than the Hubble Space Telescope has in 30 years. A piece of your cortex the size of a grain of sand can hold enough information to store every movie ever made. The total storage capacity of the human brain is estimated at around 200 exabytes, roughly equal to the entire digital content of today's world. And it does all this on the energy of a single blueberry muffin a day. Try running your laptop for 24 hours on a muffin, and see how that goes. The brain's real genius lies in its connections. It contains about 86 billion nerve cells, or neurons. Each neuron connects with thousands of others, creating trillions upon trillions of connections. As neuroscientist David Eagleman puts it, you have as many connections in a single cubic centimeter of brain tissue as there are stars in the Milky Way. It's in this impossibly complex web that your intelligence, your personality, and your consciousness reside. And it's a master of illusion. Take vision. When you look around, the image landing on your retina is upside down, two-dimensional, and riddled with holes from blood vessels and a blind spot where the optic nerve connects. Your brain flips the image, fills in the gaps, and constructs a seamless, three-dimensional world for you. But it does something even more incredible. It takes about 1/5 of a second for all that visual information to travel to your brain and be processed. In a world where split-second decisions can mean life or death, that's a dangerous lag. So your brain does something truly mind-bending. It continuously forecasts what the world will be like 1/5 of a second from now, and that's what it presents to you as the present. This means you never see the world as it is, but as it will be a fraction of a moment in the future. You spend your entire life living in a world that doesn't quite exist yet. It manufactures all your senses. Photons of light have no color. Sound waves have no sound. Scent molecules have no smell. All the richness of life, the greenness of trees, the sound of music, the scent of rain, is created inside your head. Your brain isn't a passive receiver of information. It's the composer of your reality. And yet, for all its power, it's strikingly unreliable. Our memories aren't like files in a cabinet, fixed and permanent. They're more like Wikipedia pages. You can go in and change them, and so can other people. Psychologist Elizabeth Loftus discovered she could implant entirely false memories into people's heads through suggestion, convincing them they were once lost in a shopping mall as a child, or even that they met Bugs Bunny at Disneyland, which is impossible, since Bugs is a Warner Brothers character. After the 9/11 attacks, psychologists recorded detailed statements from 700 people about where they were when they heard the news. A year later, they asked again. Nearly half the people contradicted their own original stories in significant ways, but were completely unaware their memory had changed. This is because memory is an act of reconstruction, not playback. Each time you recall a memory, you rebuild it, and it can be subtly altered in the process. Our understanding of this incredible organ has been a long and often brutal journey. One of the most famous cases in neuroscience was Phineas Gage, a railroad worker in Vermont in 1848. An explosion sent a 2-foot-long iron rod straight through his cheek and out the top of his head. Miraculously, he survived. But he was no longer Gage. The once easygoing popular man became moody, profane, and unreliable. His case was the first real proof that physical damage to the brain could transform personality. This led, decades later, to one of the darkest chapters in medical history, the frontal lobotomy. In the mid-20th century, a doctor named Walter Freeman traveled across America, performing thousands of lobotomies. His method was swift and brutal. He would insert a household ice pick through the patient's eye socket, tap it through the skull with a hammer, and wriggle it around to sever connections in the frontal lobes. He operated on people for everything from schizophrenia to depression to simple rebelliousness. One of his most notorious failures was Rosemary Kennedy, sister of the future president, who was left incapacitated for the rest of her life. The procedure, for which its inventor won a Nobel Prize, was a horrific example of how little we understood the delicate machinery of the mind. The brain controls everything, but it's powered by one of the body's most relentless and single-minded organs, the heart. The heart looks nothing like a valentine. It sits more centrally in your chest than you probably think, and despite what poets say, it's not the seat of your emotions. It has no time for distractions. It has one job: to beat. It beats about 100,000 times a day, 3.5 billion times in an average lifetime. And these aren't gentle pulses. The jolt is powerful enough to send blood spurting up to 10 feet if your main artery, the aorta, were severed. Every hour, your heart pumps about 70 gallons of blood, more than you're likely to put in your car in a year. Over a lifetime, the work it does is equivalent to lifting a 1-ton object 150 miles into the air. It's a truly remarkable machine. And it sits at the center of a vast network. Your blood vessels, arteries, veins, and tiny capillaries would, if laid end to end, stretch for some 25,000 miles, enough to circle the earth. The blood flowing through them is a river of life. We all know it carries oxygen, but it does so much more. It transports hormones, carries away waste, fights off pathogens, and regulates your temperature. A single drop of blood contains about 4,000 different types of molecules, which is why a blood test is such a revealing window into your health. The bulk of your blood is made up of plasma, which is mostly water, and red blood cells. These cells are essentially tiny shipping containers, packed with a protein called hemoglobin, which grabs onto oxygen in the lungs and delivers it throughout the body. Each red blood cell makes about 150,000 round trips through your body before it wears out and is quietly retired in the spleen. You discard about 100 billion of them every day. For centuries, our understanding of blood was disastrously wrong. The prevailing theory, dating back to the ancient Greek physician Galen, was that blood was continuously made in the liver and burned up by the body. This led to the terrifying practice of bloodletting. Doctors believed most illnesses were caused by an excess of bad blood, and the solution was to drain it out. George Washington, suffering from a throat infection, was bled of about 40% of his blood by his well-meaning doctors. The treatment, not the illness, almost certainly killed him. The practice persisted for an extraordinarily long time. Britain's leading medical journal, The Lancet, is named for the instrument used to open veins. The truth that blood circulates in a closed system, pumped by the heart, was discovered in the 17th century by William Harvey, but his theory was almost universally ridiculed. It was only in 1900 that Carl Landsteiner discovered blood types A, B, AB, and O, which he actually intended as a 0 for zero antigens. This explained why early blood transfusions so often failed and opened the door to modern surgery. Surgery became truly revolutionary with the dawn of open-heart procedures. It took incredible bravery. In 1929, a young German doctor named Werner Forssmann, curious to see if he could reach the heart directly, fed a catheter into an artery in his own arm and pushed it all the way into his chest until it touched his beating heart. He then calmly walked to the X-ray department to have a picture taken as proof. His discovery would revolutionize cardiology, and he eventually won a Nobel Prize for it. Today, we can replace faulty valves, bypass clogged arteries, and even transplant the entire heart. But heart disease remains the Western world's #1 killer. Much of this is due to what are called mismatched diseases. We're born with the bodies of hunter-gatherers, designed for a life of constant movement and scarce food. But we live in a world of couches and cheeseburgers. And that brings us to the journey of food. From the moment you put something in your mouth, your body begins a complex process of deconstruction. Your 12 salivary glands produce about 1.5 quarts of saliva a day, packed with enzymes that begin breaking down carbohydrates while they're still in your mouth. When you swallow, it's not just gravity at work. 50 different muscles coordinate to push food down your esophagus. We are, uniquely among mammals, built to choke. Our larynx sits lower in our throat, an adaptation that gave us the ability for complex speech, but it means our air and food passages cross. Only a tiny flap, called the epiglottis, prevents food from going down the wrong pipe. The stomach is essentially a muscular bag that churns food and bathes it in hydrochloric acid, but the real work of digestion happens in the 25 feet of coiled tubing, called the small intestine. Its inner walls are lined with millions of tiny finger-like projections called villi, which increase its surface area to about 1/2 acre. This is where nutrients are absorbed into the bloodstream. Whatever's left over, mostly fiber, is passed on to the large intestine, or colon. This is essentially a fermentation tank, home to those trillions of bacteria we met earlier. They feast on what we can't digest, and in the process they produce vital vitamins for us. At the junction of the small and large intestines is a small, finger-like protrusion you've probably heard of, the appendix. For centuries, it was considered a useless evolutionary leftover. Its only known functions seem to be getting infected and killing you. We now think it might serve as a safe house for our good gut bacteria, a place for them to hide out and repopulate the gut after a serious illness. This whole digestive system is an amazing feat of chemistry, designed to extract just 3 essential things from the 60 tons of food you'll eat in a lifetime: proteins, carbohydrates, and fats. Proteins are the building blocks, carbohydrates are your primary fuel, and fats are your energy reserves. Your body is designed to burn carbs first and store fat, a useful survival mechanism from a time when the next meal was uncertain. Now it's a primary reason for our expanding waistlines. The world of nutrition is a minefield of confusion. Ancel Keys, a nutritionist from Minnesota, became famous in the 1950s for his 7-country study, which linked dietary fat to heart disease and gave us the Mediterranean diet. But his work has since been criticized for cherry-picking data. Today, the villain is sugar. The average American consumes 22 teaspoons of added sugar a day. World Health Organization recommends a maximum of 5. It's hidden in everything from bread to ketchup. Your liver doesn't know if the sugar came from an apple or a can of soda. As one nutritionist told Bryson, the easiest way to shop for healthy food is to stick to the outside aisles of the supermarket. That's where you find fresh produce, meat, and dairy. The inner aisles are almost entirely filled with processed foods. All this machinery, the skin, the brain, the heart, the guts, is supported by a remarkable framework, your skeleton. You have 206 bones, though that number can vary. More than half are in your hands and feet. We tend to think of bones as inert scaffolding, but they're living, dynamic tissue. They manufacture blood cells, store chemicals, and even produce a hormone called osteocalcin, which may help bolster our memory and our moods. Bone is an engineering marvel. It's stronger, pound for pound, than reinforced concrete, yet light enough to allow us to run. It's also the only tissue in the body that can heal without a scar. Connecting this framework are tendons, which link muscle to bone, and ligaments, which link bone to bone. And then there are the muscles themselves, more than 600 of them, making up about 40% of your body weight. Nowhere is this intricate choreography of bone and muscle more beautifully demonstrated than in the hand. With its 29 bones and dozens of muscles, it's what allowed us to grasp, to manipulate tools, and to build civilization. But the real story of our skeleton is the story of how we came to stand up. About 6 million years ago, our ancestors began the slow, profound transition to bipedalism, walking on two legs. It was a trade-off. It freed our hands, but it came at a cost. It required a complete redesign of our anatomy. Angled thigh bones, a sinuous spine, arches in our feet, and a massive muscle in our buttocks, the gluteus maximus. It also gave us a legacy of back pain and knee problems, as we put a lifetime of pressure on a skeleton designed for 4 legs. And most dramatically, it narrowed the pelvis, making human childbirth uniquely painful and dangerous. A baby's head is, on average, an inch wider than a mother's birth canal. It is, as Bryson notes, the most painful inch in nature. This brings us to the very beginning, and one of the most fraught journeys any of us will ever take. Every woman is born with all the eggs she'll ever have. A 20-week-old female fetus already has 6 million eggs inside her. A man, by contrast, produces sperm constantly, at a rate of about 1,000 a second. The journey of the sperm is heroic but foolish. Of the hundreds of millions released in a single ejaculation, nearly all will fail. They're terrible swimmers with no sense of direction. The chance of a single act of sex resulting in pregnancy is only about 3%. But if one lucky sperm does find the egg, a new life begins. It takes just 41 cycles of cell division to go from that first fused cell to a fully formed baby. By 3 weeks, the embryo has a beating heart. By 280 days, you have a new human. As the baby passes through the birth canal, it's swabbed with the mother's personal collection of microbes, its first inoculation, and the beginning of its own unique microbiome. Babies born by C-section miss this, which may explain why they have higher rates of allergies, asthma, and diabetes. We're only just beginning to understand how crucial our first 1,000 days, from conception to our second birthday, are for our long-term health. The Barker hypothesis suggests that what happens in the womb can influence your risk of heart disease and cancer decades later. Life is a constant precarious balancing act. We live within an extraordinarily narrow range of temperatures. A shift of just a few degrees in your core body temperature can be fatal. This state of internal equilibrium is called homeostasis. But even when we're perfectly healthy, there's a process we must all submit to, one of the most mysterious things we do: sleep. We spend 1/3 of our lives doing it, and we don't know why. If sleep doesn't serve some absolutely vital function, it's the biggest mistake evolution ever made. We know it's more than just rest. It helps consolidate memories, restore hormonal balance, and clear out toxins from the brain. But why must we become completely unconscious and paralyzed to do it? We cycle through stages of sleep every night, but the most mysterious is rapid eye movement, or REM sleep. This is when we do most of our dreaming. Our brain becomes as active as when we're awake. Our eyes dart about, but our bodies are paralyzed. It may be to prevent us from acting out our dreams and hurting ourselves. And then, there are the times when, despite all our body's best efforts, things go wrong. Diseases are a curious thing. Some, like the mysterious sweating sickness that ravaged England in the 16th century, appear from nowhere, kill thousands, and then vanish forever. Others, like the flu, are a constant, mutating threat. The deadliest infectious disease on the planet today is tuberculosis. 1/3 of the world's population carries the bacterium, though most never get sick. Smallpox, by contrast, was probably the most devastating disease in history, killing up to 500 million people in the 20th century alone. But because it only infected humans, it had nowhere to hide. In 1980, it was declared eradicated from the earth, the only human disease we've ever made extinct. But the greatest fear for most of us isn't a disease we catch, but one that comes from within: cancer. Cancer is your own body trying to kill you. It's suicide without permission. It happens when your own cells forget how to die. Normal cells have a built-in program for self-destruction called apoptosis. They do their job, and when they get old or damaged, they quietly eliminate themselves for the good of the whole. Cancer cells refuse this order. They divide without limit, grow without direction, and spread to other parts of the body. They're selfish. Our fight against cancer has been brutal. Early surgery, like the radical mastectomy pioneered by the drug-addicted genius William Halsted, was more like excavation than operation. Radiation therapy was discovered by accident and came with horrific side effects for its pioneers. Chemotherapy was born from the horrors of mustard gas used in World War I. Today, survival rates for many cancers have improved dramatically. For childhood leukemia, a disease that was once a death sentence, the survival rate is now 90%. But the treatments are still punishing. As one cancer specialist told Bryson, we're basically still using mustard gases. And so we come, at last, to the end. Aging is universal, but we have no idea why we do it. One of the most famous discoveries was the Hayflick limit. In 1961, Leonard Hayflick found that human cells in a lab can only divide about 50 times before they stop. It's as if they have a built-in death clock. This led to the discovery of telomeres, the protective caps at the ends of our chromosomes, which shorten with each cell division. But arresting the shortening of telomeres isn't the fountain of youth. It turns out aging is far more complex. We're all dying. Some of us are just doing it more quickly than others. For the first time in history, more people now die from non-communicable lifestyle diseases than from infectious ones. We are, in effect, choosing how we die. About 60% of us will experience a long, protracted decline. We've gotten much better at extending life, but not necessarily at extending the quality of life. As Daniel Lieberman noted, for every year of life we've gained since 1990, only about 10 months of it is healthy. In the end, we all face the same fate. Death begins almost at once. The blood drains from the skin. The body cools, internal cells rupture and begin to digest themselves. But a corpse is still very much alive. It's just not your life anymore. It's the life of the trillions of bacteria you leave behind as they set about the final, relentless task of returning your atoms to the universe. And that's you, gone. But as Bryson so beautifully reminds us, it was good while it lasted, wasn't it? As we come to the end of this incredible tour of the human body, what strikes me most isn't just the sheer volume of fascinating facts, but the profound sense of wonder that Bill Bryson weaves into every page. We live inside this body our entire lives, yet we take it almost completely for granted. We treat it like a car we never bother to look under the hood of, just hoping it keeps running. But as this book so beautifully reveals, your body isn't a simple machine. It's a universe, a dynamic, self-healing, impossibly complex ecosystem working tirelessly every moment of every day, simply to keep you alive. The most powerful lesson from the body is a call to appreciate this miracle. It's a call to look at your own hands, to feel your own heartbeat, to take a deep breath, and to feel profound gratitude for the incredible, improbable gift of your own existence. This isn't just abstract science. It's the most personal story you'll ever know. And with that understanding comes a responsibility to be a better occupant. If I could distill the wisdom of this book into a few simple actions you could take today, they'd be these. First, simply move. Our bodies were designed over millions of years for endurance. We evolved to walk, to run, to throw. The simple act of going for a walk isn't just exercise. It's an expression of what it means to be human. It's the cheapest, easiest, and most effective medicine we have. Don't let that incredible evolutionary inheritance go to waste by spending your life on a couch. Second, be kind to your microbes. Those trillions of little passengers in your gut are your partners in life. They influence your mood, your weight, your immunity. The best way to care for them is to feed them what they love. Fiber. Eat more vegetables, more whole grains. A happy gut is a happy you. And third, appreciate the mystery and necessity of sleep. We live in a culture that often treats sleep as a weakness, an inconvenience to overcome. But as we've learned, sleep is a vital, active process of repair and restoration. It's not wasted time. It's the tune-up that allows your body and brain to function at their best. Prioritize it. Ultimately, this book is a humbling reminder that we're both incredibly resilient and exquisitely fragile. We're the product of billions of years of evolution, a chain of survival so long and successful it's almost impossible to comprehend. And yet our existence is a delicate balance, a constant negotiation between health and disease, life and death. That was a summary of The Body, A Guide for Occupants by Bill Bryson. We've journeyed through the incredible landscape within us today, but I'll be honest with you, a summary can only ever be a map. The real adventure happens when you explore the territory yourself. The true magic of a book like this is in the quiet moments of discovery, when a particular story or a simple turn of phrase makes you see yourself and the world in a completely new light. This summary is your invitation to that journey. If anything we've talked about today has sparked your curiosity, I urge you to pick up a copy. Reading it isn't just about learning facts. It's an experience that can genuinely deepen your appreciation for the simple, staggering miracle of being alive. Also, if you found this summary valuable, please consider liking this video and subscribing to the channel. It lets me know that these journeys matter, and it ensures you won't miss our next exploration into another life-changing book. Let's keep learning and growing together.